In this lesson, we're going to factor to solve equations with squares. So far in this chapter, we've been solving quadratic equations. Anything with an x squared in it is a quadratic equation. One of the methods that we learned in solving quadratics is that we can solve some of them like a fence problem. If I don't have an x and just have an x squared, then I can go ahead and I can get the variable by itself, and we have 2x squared is equal to then 14. And then just like we do with our equations, linear equations, we can divide by 2. And then to undo this x squared, we're going to take the square root, and we'll have x squared is equal to plus or minus the square root of 7. You could either write that as a decimal, or you can just leave it just like this. All right, number 2. Notice how we can't solve this one by using the fence problem because I have an x squared and an x. But in this one, take a look, is that we can undo the distributive property by factoring out what they have in common with the greatest common factor. So I'm going to factor out a 3x from both of these. And then we've got these two equations here. We've got the 3x is equal to 0, and then we have the 2x minus 9 is equal to 0. So x is equal to 0. And then I'm going to add the 9, so I've got 2x is equal to 9, and then we'll divide by 2, so x is equal to 9 all over 2. And so these are our two solutions. All right, so let's look at number 3. First of all, we know we can't solve this using the fence problem. We have an x squared and an x. We can subtract the 4 to make this then equal to 0. And so I'd have x squared plus 7x plus 10 is equal to 0. Now we know that we can't factor anything out by undoing the distributive property. There's not something that can go into x squared to 7x plus and 10. So instead what we're going to look at is we're going to look to see, can we factor this by undoing the foiling, because we've got this trinomial. So what we have here is we're going to make up these two binomials. And remember, the binomials we add to the two numbers with the operation in there. And so if we're looking to undo this, let's look at what would have made up this x squared. Well, we know that x times x makes up the x squared. All right, and so because if you came back here, I could say x times x was x squared. Now let's take a look at this, the 10 right here. And so, because remember, we know that this multiplied is going to be equal to that. And so we have the factors of 10 are 1 and 10 and 2 and 5. So we need to pay attention to this middle term right here. And remember that when we FOILed, then that these two right here ended up adding together. All right, once you put those numbers in there. So let's take a look at what this looks like. So we're looking to make the 7x. And so we know that we would then choose the 2 and the 5, we know are going to make up 7. So if I put in a 2 right here, and I put a 5 right here, and I'm going to put pluses, that now when we FOIL it, I will end up with a 2x right here and then a 5x, and we know that those would add up to make our middle term. So now that we have it factored out, what we're going to do then is just like we did in our last problems, is we are going to then, we have x plus 2 is equal to 0, and then we're going to have the x plus 5 is equal to 0. And so x is equal to negative 2, and then x is equal to negative 5. All right, so let's just practice just the factoring right now. So we're going to look at this, and we're going to factor it into two binomials. And let's start then. Remember, we're going to have to fill these parts in, and we have to think about what's going to make up that m squared. And we know that an m and an m are going to equal the m squared. Now we need to take a look at this 14, and let's write down the factors of 14. So what's making up this 14 right here, we could have a 1 and a 14, and we could have a 2 and a 7, all right? So let's think then, which ones could then, when we add them together, or we could end up subtracting, are going to equal this 9m right here. And we know that 2 plus 7 is going to equal to 9, so we're going to use the 2 and the 7. So we will place a 2 right here, and the 7 right here. And then let's just double check. Let's check our work here. So if we went to make sure that it works, we'd have our m and m. We'd have our m squared, and then we'd have plus 7m plus 2m, and then plus 14. And then we'd have m squared plus 9m plus 14. And notice how we're back to our original problem. All right, let's take a look at another one. All right, so again, we're going to factor out. And again, we've got an x and we've got an x. And then let's list the factors then of 18. I could have 1 times 18. I could have 2 times 9, and then I can have 3 times 6. Now remember, we're trying to make this 11x in the middle and how they add together. And so right here then, we could take the 2 and the 9 to make that. So I will have a 2 and a 9. And again, then you could check it by foiling, and then you would end up with your original problem. All right, question number 3. Now notice how we have a minus in there. So this is going to look a little bit different. So again, we'll start with our x, and we'll look at our x. All right, and now let's list our factors of 8, and we'll have 1 times 8, and then 2 times 4. Now, so we need to try to make a negative 6x is what we're trying to make. And we know that 2 plus 4 is going to give us 6. So let's start there. So we'll have a 4 and a 2. All right, so now first of all, when we look at this right here, we have our 2 times 4. This has to be a positive 8, but we need to have a negative 6 in the middle. And so instead of placing a plus there, what if we placed our minuses? And so now we would have then our x times x is x squared. Our middle terms, we'd have negative 2x and negative 4x. And that's in fact, that's going to make the negative 6x in the middle there. And then negative 2 times negative 4 equals positive 8. All right, so we have a negative there again. So let's start by making the 2 binomials. And we know we have an x and we have an x. Now let's list out our factors. I'm going to have a 1 and a 3, and then that would be the only factors. So we know that we're going to have a 1 and a 3. And now again, we need to make a positive 3, but we need to make a negative 4. So we'll end up with a negative 1 and a negative 3. So x minus 1 times x minus 3. All right, so we have, in this case now, we have a positive m, but notice how we have a negative for our third term here. So again, we're going to start by making our binomials, and I know I'm going to have an m, and I know I'm going to have an m. So I'm going to list my factors, and I would have 1 times 20, 2 times 10, and 4 times 5. All right, so now we know that we have a 1 right here. And again, we're trying to make this right here. And because we have a negative, we know that one of them is going to have to be a negative and one's going to have to be a positive. And so let's take a look at now putting them together. If I were to subtract them, that I could make a 1. So if I have my 4 and my 5, 5 minus 4 is going to be equal to 1. So let's go ahead and put a 4 and a 5. All right, now we have to determine which one's going to be negative and which one's going to be positive. So if we kind of look here, and I come here, this would be a 4 and we'd have a 5 if we multiplied that together then there. All right, so we have a positive 1m, and so we know that this is going to have to be the positive, and then this one would have to be the negative because we want to make that positive there. So in order to do that then, I would have to have a plus 5, but then a minus 4. All right, we have y squared minus 5y minus 24. So again, we're going to make our two binomials, and I'm going to start with my y and my y. The factors of 24, we would have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. All right, so again, we're trying to make this negative 5y there. And so I'm going to look at using then my 3 and my 5, because I know one could be a negative, one could be a positive. And so I will have then 8 and 3. So now let's go back and take a look at what we have. We have 3y and 8y when you multiply the outside term, or the here. All right, so now we know that one has to be a negative, one has to be a positive. And so I'm making my negative 5y. So I know that in order to get a negative, that 8 is going to have to be a negative to get the negative 5. So we're going to place a negative right here, and then this one's going to be a positive, and this now here is in factored form.